Hey guys, this is the Unit 3 test review, Part A. I'm recording this outside in the backyard, so if you hear pigs snorting or chickens clucking, then don't mind that. Alright, here we go, Part A. The figure below is a rectangular solid, blah blah blah. Name the plane that is parallel to, parallel to plane KLP. So we can underline the important stuff there, but we need to find plane KLP. Plane KLP is the side of this box that has K, L, and P. So that looks like this line, or this side back here. To me, it looks like the back of the box. To some of you, it might look like the front of the box. I don't know, but to me, that looks like the back of the box. So KLP looks like the back of the box, and we want to find out the side of the box that it's parallel to. So what side of the box is going to run the same direction and never intersect the KLP side? So since KLP looks like the back of the box, the side that would run parallel to it should be this front of the box. All right, and we could name that any combination of J, M, N, and R. So plane, I'm just gonna call it J, N, M. But any combination of J, N, M, and R would do the trick. So as long as you have 3 of those 4 points. Part B says classify each of the segments as parallel, perpendicular, or skew to line QR. So what I'm gonna do is I'm gonna find QR. What's up, QR? How you doing? There it is. There's QR, and we want to compare that to line JN first. So let's compare that to line JN. All right. So check out those 2 lines, and let's see. They're definitely not parallel, but are they going to be perpendicular? And the answer is no, they're not going to intersect at a right angle. In fact, they're not going to intersect at all. Let's think what's going to happen here. If this line kept going, these lines would never intersect, but it's not because they're parallel. It's because they're on 2 different planes, okay? They're just going to miss each other because they're on 2 separate planes, and we call that skew. So JN is skew to QR. All right, up next we got LQ. So let's identify LQ. There you are, LQ. And it's definitely intersecting RQ. So it's not going to be parallel or skew. And it is going to be perpendicular, but there's no right angle there. Well, they told you that this was a rectangular solid. So there actually is a right angle there. So LQ is perpendicular. We're going to abbreviate that. Perpendicular to QR. All right, and then last up we have NP. So remember, our original is this QR. Okay, our original was QR here, and we're looking at NP now. And I want you to see how those are running. Look at that. They're like best friends running alongside each other. So those 2 would surely be parallel. They're not going to intersect. And they're both on that bottom plane of the box. So NP, RQ, parallel to each other. All right. Up next, we're going to classify each angle pair. So let's remember all of our angle pairs. All right, so let's draw a little doohickey over here. All right, the first one we learned was corresponding angles. And that was angles that were in the same position, but a different group. So see how 1 is in the top left of its little group of angles, and 2 is in the top left of its little group of angles. So the first thing we learned was corresponding angles. All right, the next one we learned was alternate exteriors. So that would be like, hey, I got angle 3 over here and angle 4 over there. They're on opposite sides of the transversal. Let's draw that transversal right there. Transversal is the line that cuts through. So alternate exteriors were on opposite sides of the transversal. Alternate exterior. And then we learned about some interior ones. We learned about alternate interiors. And let's say I have this angle 2 right here. The alternate interior with it would be on the other side of the transversal, but still on the interior of the group there. So angle 5 and angle 2 would make alternate interiors. All right, and then we also learned about same side interiors, and that would be like angle 5 there, and let's call this angle 6. Angle 5 and 6 would be same side interiors. Same side interiors because they're both on the interior and they're on the same side of the transversal. So a little recap of all of those. We still have our linear pairs and vertical angles too. So if I got that angle 2 over here, then I could have an angle 7 that would be vertical with it. And then we also have our linear pairs. If I have, let's say, look at angle 1, and then angle 8 would be a linear pair with angle 1. All right, so we have all of our relationships that we've learned, and we're trying to figure out what 2 and 7 are in this diagram. So let's check out angle 2 and angle 7. Well, we see that they're both on the exterior, and they're on opposite sides of the transversal. So since they're on opposite sides, we'll say that they're alternate, and they're on the exterior, so they're alternate exterior. All right, up next we have 5 and 3. So 5 and 3, 5 and 3, 5 and 3, 3, 3. Well, they're both on the interior. Okay, so they're definitely going to be interior angles. And 5 and 3 are on the same side of a transversal, so we'll call them same side interiors, also known as consecutive interiors. All right, so you might see them written as consecutive interiors on the test. All right, and we got 3 and 7. Angle 3 and angle 7. That's my dog. Be quiet, dog. Angle 3 and angle 3 is in the bottom left of its group. Angle 7 is in the bottom left of its group. So we would call those corresponding angles. They correspond with each other. That's my favorite type. What's your favorite type? Up next we have 4 and 5. Angle 4 and angle 5 in there. They're both on the interior, so we're going to call them interior angles, and they're both on opposite sides of the transversal, so we'll call them alternate interiors. Cool, cool. And then number 3, find the measures. So we did a good job there. We did awesome. Dog, be quiet. Find the measures of all the angles. All right, well, we learned that correspondings are going to be congruent. Oops, that's the worst congruent sign ever. Hey, Fender, we're trying to work here, man. Chill out. We learned that alternate exteriors were congruent. We learned that alternate interiors are congruent, but we did learn that same sides, they were different, man. Same side interiors, those were supplementary. All right, so we need to be on the lookout for that. So we know that this guy's 65 down here. So what I would do is I'm like, all right, well, the vertical angle, angle 8, is 65 degrees as well. Then you could talk about corresponding angles. Well, angle 8 corresponds with angle 4. So they're corresponding, therefore they are congruent. So angle 4 is 65. And if 4 is 65, then 2 is 65. So cool, we have 4 65-degree angles in there. We could also talk about linear pairs. If we had a 65-degree angle to start with, then that 7 is going to be supplementary to it because they're a linear pair. So I know that those have to add up to 180. So that means to find angle 7, you'll do 180 minus 65, 115 degrees. And then you have your vertical angle, 115 degrees. And then you could say that 7 and 3 are corresponding, so 3's got to be 115. And then you have your vertical, another 115. All right, and before you know it, we got all the angles in the figure. We did it. Remember, you only have two choices. The angles are either congruent or supplementary. All right, next. Okay, so find the value of each variable. We did this in pretty much every class, but I'm going to start with the x because that's what they tell me. And boop, 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 boop. And I don't really even know what to call those angles. One's interior, one's exterior. They're on opposite sides. I don't have a name for this. But what I do know is that the 3x is acute, and the 9x plus 12 is obtuse. So remember when I said they're either going to be congruent or supplementary? Well, if they're two different types of angles, there's no way they're going to be congruent. Those suckers are going to be supplementary, which means that they add up to 180. So I'm going to add them together to get 180. So my equation to find x is going to look like, I'm going to add them together. So I'm going to have 3x. Okay, I'm going to have a 9x plus 12. 9x plus 12. Add them together to get 180. Be careful with your algebra. Make sure you combine your like terms here. 3x's and 12x's, or sorry, 3x's and 9x's means I have 12x's. That's a lot of x's. That's too many. All right. And so 12x plus 12 equals 180. Do some subtraction. Do some algebra. The subtraction property of equality. All right. A little division, x equals 14. All right. So if x is 14, you know what I did? I plugged that back in, man. I'm like, all right, if x is 14, and that's 3 times 14, that's 42. This is going to help me with the next problem. If x is 14, then that's 9 times x. 9 times x is 100 and... no, sorry, 9 times 4... Rachel, what's 9 times 14?
90 plus 36, so 126.
Man, she's good. She is good. That's why I married her. 126 plus 12. Yeah, that was impressive. 100, yeah. 138. Cool. So if I wanted to write an equation to find y, man, I could do it with the 4y minus 10. All right, that's a good place to start. And what I could do is I could use this 42 here that we just found. So what is the relationship between those two angles? The 4y minus 10 and the 42 degrees. So I'm imagining right now you're all listening on your phones or on your computers and you're like, it's a linear pair. It's a linear... It is. So they should add up. So I'm going to add them together. 4y minus 10 plus 42. And a linear pair, so they add up to 180. You notice how everything is basically they're equal or they add up to 180. It's not that hard, guys. You can do this. I believe in every one of you. Subtract. What's that? 148. And then you divide by 4 and y equals 37. All right. So that's how we do that one. And number 5. Oh, we're doing so good. Number 5. And look at these, man. Same deal. These are same side interiors. And I know that same side interiors add up to 180. But if you didn't know that, if you forgot, one of these is acute. The other is obtuse. So there's no way they can be equal to each other. So I know that they have to add up to 180. 3x minus 4 plus x plus 10 has to add up to 180. All right. We got 3x, we got 1x. That makes 4x's. Minus 4 and plus 10. There it goes. All right, so we combine like terms. Now we have a nice two-step equation. Subtract 6. 4x equals 174. Divide x equals 43. 43.5, I think. All right. I got no calculator. I'm out in the backyard. So x is 43.5. Cool, cool. And then they want us to find the measures of both of those angles. Well, I'm going to do the easy one first. This one's x plus 10. And I know that x is 43.5. So the substitution property, 43.5 plus 10 makes 53.5. So one of these angles is 53.5. The other one, oh, gross, is 3 times 53. Three. The other one is 3 times 43.5 minus 4. We're replacing, substituting for the x. What is that? That's going to be 130.5, I think, minus 4, which is 126.5. Not bad for no calculator. Cool, cool. I think we're getting clean. All right, complete the proof. Now, remember, on your test, you will have a nice, pretty word bank to build off of. But on this one, we got to go from the brain. You got to use your noggin. How do we know this stuff? Man, you know that stuff because it's given to you. All right, and then if I said something is congruent, you know that means that they're equal to each other. And you know that because that's the definition of congruent. Now, remember, you are going to have a word bank, but I expect you to know stuff like that. Okay, up next. So number 4, we're going to say things are supplementary. So if I'm saying it's supplementary, how do you know it's equal to 180? Well, that's the definition of supplementary. Cool, cool. And then in the next part, they're just, all they did was they changed the angle 2 to an angle 3 because they're equal to each other. So they switched it out with an angle 3. So the property that switches something out, that replaces something, is the substitution property. All right. And now we're back to this. If it equals 180, then it's supplementary. So same deal, man. That's the definition of supplementary. Okay, because we know the definition of supplementary is if things are supplementary, then they equal 180. And it goes both ways because that's how definitions work. All right, last one. Here we go. Cool, cool. Now with this, it's important to know your symbols. Know your symbols. We got parallel. We got perpendicular. We got congruent. And we got equals. All right, so when I do a problem like this, man, you got to know your stuff. You even got to know how to find angle SPY. Angle SPY goes through S, vertex at P, goes through Y. There's that angle right there, right there. And then angle MRB, MERB. All right, angle MERB goes through M, has a vertex at R, and then goes through B. All right, there it is. So you really could have said, well, if you said angle P and angle R, it would have been confusing because there's several angle P's and R's. This one tells you exactly which one. So look at those two angles. And what do you know about them? Well, they're corresponding angles. That's something we know. And we know that when we have parallel lines, which these are supposed to be, that those corresponding angles are going to be congruent. So SPY and MERB are going to be congruent angles. Oh man, I just gave away the answer to this one. Line XY, whoop, and line RK, whoop. What symbol goes between those? Well, I've already ruined it. They're parallel to each other, so let's use the right symbol. All right, and then the last one over here, again, know what you're looking at. We're looking at line RK and line PQ, or segment RK and segment PQ. And, well, I've already used parallel. I've already used congruent. So let's talk about those two lines. Look at them, man. They make a 90-degree angle. They're perpendicular to each other, dude. Cool, cool. And now we have segment KP. So segment KP, endpoint at K, endpoint at P, and segment KQ. What can we say about those? Well, first of all, there's only one thing left, but also we see that those are equal to each other. I guess we could even put the symbol in there. So by the definition of congruence, segment KP is congruent to segment KQ. Cool, cool. All right, guys, that was a long video. Keep working hard. I got one more to make. See ya.